Okay, welcome to the deep dive. Today, we're taking a close look at biochar. It's this really interesting substance, kind of old in concept, but now very cutting edge.
Right, people are talking about it a lot for climate change and for agriculture too.
Exactly. And we've got some sources here from a company called Net Zero. They're all about producing biochar, so we're diving into their materials, what they're doing, how they make it.
Yeah, our mission for this deep dive is basically to get you up to speed quickly. What is biochar? How's it made? What are the benefits for the planet, for farms, and how net zero is actually trying to scale this thing up?
Okay, let's jump in. So the basics first. What is biochar?
Well, the sources describe it as essentially a charcoal-like material, but it's made specifically from renewable organic matter.
And Net Zero is very clear they only use agricultural residues. So leftovers from farming?
Leftovers like what? Things like coffee husks, cocoa husks too, sugarcane bagasse, that fibrous stuff left after crushing cane, coconut shells, peanut shells, cashew shells, even those empty bunches from palm oil fruit, stuff that's usually just waste.
Right, turning waste into something useful. How do they actually do that? What's the process?
It's called pyrolysis.
Yeah.
Pyrolysis.
Pyrolysis, okay.
Yeah, and it's not burning. That's key. You heat the material intensely, but crucially, in an environment with very little or ideally no oxygen.
Ah, so it doesn't combust.
Exactly. Instead, the heat breaks down the molecules and rearranges them into this very, very stable, solid form that's packed with carbon. That solid stuff is the biochar.
Okay, so you're locking the carbon into this durable material instead of releasing it by burning.
Precisely. And actually, a neat side effect is that the process itself generates energy. Renewable gases and heat come off it.
Oh, interesting.
And net zero, they capture that. They use some for their own operations, naturally, but they can also supply excess power like electricity or heat to, local partners.
No, that makes a lot of sense.
Yeah.
Very efficient. Now, the sources also say that while biochar could potentially be used for other things, Net Zero is really focused on one main application.
Yeah, their focus is squarely on agriculture, mixing it into the topsoil.
Right near the plant roots, basically.
That's the idea, especially in the tropical regions they operate in.
Okay, let's dig into those benefits then. First, the climate side. How does putting this stuff in the soil help with climate change?
Well, the main thing is that biochar is mostly carbon, very stable carbon,
And where did that carbon come from originally?
from the atmosphere. Plants pull CO2 out of the air through photosynthesis to grow, right?
Right.
So that carbon is in the plant material. Pyrolysis then takes that captured carbon and stabilizes it, locks it into the biochar structure.
So instead of the plant decomposing and releasing the CO2 back relatively quickly.
Exactly. This carbon, in the biochar form, stays put in the soil. The sources say for at least hundreds of years.
Hundreds of years. Wow. That really is long-term storage. That's the high permanence carbon removal they talk about.
That's the term, yeah. You're taking carbon out of the active cycle and storing it long-term underground.
And what's the potential scale of this globally?
The sources mention the IPCC, the Intergovernmental Panel on Climate Change. Their estimates suggest biochar, if done right, sustainably and worldwide, could remove somewhere between 1 and 2 billion tons of CO2 from the atmosphere every year.
1 to 2 billion tons a year. Okay, that's a significant number. That could really make a dent.
It definitely got potential as part of the bigger carbon removal picture.
Okay, now shifting gears a bit, the agricultural impact. You said they mix it in the soil. How does that help crops?
It acts as a soil amendment, a really powerful one. You mix it in, usually just once, and benefits last for a very long time, decades even.
So kind of like improving the soil's fundamental structure.
Yeah, that's a good way to put it. It has these unique properties. First, it's incredibly porous. Think of it like a microscopic sponge.
Yeah.
This means the soil can hold on to a lot more water, really important in places with droughts or just unreliable rain.
Makes sense. Better water retention.
Then second, its surface tends to have a negative charge. This is important because many essential plant nutrients are positively charged, so the biochar helps the soil hold on to those nutrients, stopping them from washing away.
Ah, so it holds water and helps keep the plant food nearby.
Exactly. Better access to both water and nutrients for the plants. Plus, especially in tropical soils, which can often be quite acidic, the biochar helps to kind of buffer that acidity because it's carbon rich.
Right, rebalancing the soil chemistry a bit.
Put it all together and you get significantly improved crop productivity, durably. And the sources suggest it can even help farmers shift towards fully organic farming, reducing the need for synthetic fertilizers.
Better yields and potentially less reliance on chemicals. That sounds like a win-win.
Definitely. And the sources stress that it seems particularly effective for tropical crops.
Is there data on that?
They cite one study, Jeffrey et al., from 2017, which apparently found a global average yield increase of about 25% in the tropics.
25%. Just from adding biochar.
At a certain application rate, yeah. A 25% boost is huge for a farmer's income, especially if they're also saving money on fertilizer.
No kidding. That's substantial. And Net Zero is doing more than just selling it, right? They're involved with the farmers.
Yes. The sources mentioned they provide agricultural training and support. There's even an example described from their site in Cameroon comparing maize plots.
Oh, yeah. What did they find?
Basically, maize grown only with biochar did about as well as maize grown only with synthetic fertilizer. Both were much, much better than the control plot with nothing added.
Interesting.
And the plot that had both biochar and fertilizer, that one looked the best, suggests the synergy. It really shows how biochar improves the soil itself as a foundation for growth.
That kind of visual proof must be pretty compelling for local farmers. Okay, so we get what it is and what it does. How is Net Zero actually making this happen? Building it out?
Well, they're setting up production sites. Their first big one, kind of a full-scale pilot, was in Nkongsamba, Cameroon, Africa's first industrial-scale biochar facility, apparently.
And strategically placed, I assume?
Seems so. It's right next to a big coffee processor. That gives them easy access to coffee husks for their feedstock.
Ah, the raw material.
And also a ready-made network to distribute the finished biochar back to the coffee growers who supply that processor. Smart loop.
Makes sense. What's the capacity there?
About 2,000 tons a year. And it got certified under something called the Puro Standard in 2022.
Puro Standard. What's that about?
It's a certification for carbon removal. It verifies that the carbon sequestration is real, it's measurable, and crucially, that it's permanent, or at least very long-lasting, like with biochar. So that certification basically validates the climate benefit.
Got it. Proof that the carbon's really being locked away.
Okay.
Where next after Cameroon?
Brazil. Their second plant, the first in Brazil, opened in Lagina in April 2023, and this was a bigger step up.
How so?
South America's first industrial site, and the sources claim it was the world's largest plant producing biochar just from crop residues at that time.
Wow, world's largest from residues. Okay.
Again, near coffee sources. They partner with a local cooperative there, Cucafé, representing like 10,000 growers. The biochar goes back to those member farmers.
Same model, bigger scale.
Right. And this plant introduced their Gen 2 production process. Apparently, big improvements in output, reliability, safety. It's even satellite connected for remote monitoring.
Gen 2. Okay, sounds like an upgrade.
Yep.
Capacity.
Double Cameron's 4,000 tons per year, and it got Puro certified in 2023 as well.
Doubling capacity, improving the tech, and they've just launched another one.
Very recently, yeah. June 2024, their third plant, second in Brazil, in a place called Brejatuba.
Okay.
What's notable here is that it's only about 40 kilometers, maybe 25 miles, from the first Brazilian plant in Lagina.
Oh, interesting. Close by. Is that deliberate?
Absolutely. It seems to be core to their strategy. They replicate these mid-size factories in clusters, keeping them really close to where the biomass, the feedstock, actually is.
Minimizes transport hassle and cost, I guess.
Right.
And the carbon footprint of moving stuff around.
Exactly. This new Brejatuba plant uses the same improved Gen 2 tech, probably with some further tweaks, and got its Puro certification this year, 2024.
So refine, replicate, stay local. Makes sense. What's coming next? Are they stopping there?
Doesn't sound like it. The sources say 2 more sites are already being built in Brazil for 2025, with even more tech improvements, showing they can repeat this model effectively.
Right.
And they're planning to start construction on several more projects next year, too, using that Gen 2 system, but also starting to use other types of agricultural waste, not just coffee husks.
Okay, so diversifying feedstock, continuing to build. They must have a big target in mind.
They do. The goal mentioned is removing a total of 5 million tons of CO2 by the year 2030.
5 million tons by 2030. That's ambitious. How do they get there from, 3 or 4 plants now? The sources laid out a strategy, didn't they?
Yeah, a 3-part strategy seems to be the plan. First is geographic. Why focus on tropical developing countries?
Okay, why do they focus there?
Well, several reasons, according to the materials. 1, agriculture is often huge in these economies, so there are massive amounts of crop residues generated. Cheap, available feedstock, crucially, without needing to change how land is used.
Right, using existing waste streams.
2, As we discussed, biochar works particularly well in tropical soils, boosting crop yields significantly. This directly helps farmer incomes, which is obviously a major benefit in these regions, and it makes the product very attractive to them, might even help them go organic.
So the impact is greatest where the need and the resource overlap.
Precisely. And the third reason is that energy cogeneration we talked about. The excess heat and power from pyrolysis can provide stable, renewable energy in rural areas that often lack reliable electricity. So it hits multiple goals: agriculture, social development, environment, and makes the economics work better.
Okay, that geographic focus makes a lot of sense. What's the second part? Technology strategy.
Right. Pyrolysis isn't brand new tech, but Net Zero has its own R&D focused on optimizing their system, making it easier to install and run, standardizing it, ensuring it's safe and efficient. The big move here, mentioned in the sources, is they plan to launch a fully optimized Gen 2 model in 2025 that's designed to be franchised.
Franchised, like letting other companies use their tech.
That seems to be the idea, allowing other agricultural businesses across the tropics to license and build these optimized biochar plants themselves. That's likely key to hitting that big 2030 goal scaling through partners.
That could really accelerate things if other players adopt it. Okay, and the third part, partnership strategy.
Yeah, building relationships. They work with sustainable companies, could be farmer cooperatives, could be big corporations with net zero climate targets who want to buy high-quality carbon removal credits.
Right, partners who can help distribute the biochar or fund the carbon removal.
Exactly. Maximizes impact and helps them expand. And they're also partnering heavily with research institutions. Over 15 universities and centers by 2025, the sources say, constantly studying how well the biochar works in different soils and conditions.
So a strategy built on smart locations, optimized and shareable tech, and strong partnerships. Seems pretty comprehensive.
It looks like a way to connect waste, technology, climate benefits, and agricultural improvements all together.
Okay, let's just pull this together for you, our listener. We've taken a deep dive into biochar. We learned it's this stable, carbon-rich stuff made from agricultural waste using pyrolysis.
Right. And it has this powerful dual impact.
Yeah.
It removes carbon from the air for centuries when added to soil, helping fight climate change.
And it significantly improves tropical soils, holding water better, retaining nutrients, balancing acidity, which boosts crop yields, and potentially supports organic farming.
Then we looked at Net Zero's approach. Building these industrial plants, like in Cameroon and Brazil, right near the waste sources and the farmers, refining their tech, the Gen 2 process, and setting up a clear strategy to scale up.
Yeah, that strategy focusing on tropical regions, planning to franchise their optimized technology, and building strong partnerships, all aiming for that big goal: 5 million tons of CO2 removed by 2030.
Hopefully, this gives you a really clear, quick understanding of what biochar is all about and how one company is trying to make it a large-scale reality.
Turning what we might think of as just farm waste into a valuable tool.
It's a pretty compelling example of that kind of innovation.
So here's something to think about as we wrap up. We've focused on agricultural waste today. Coffee husks, coconut shells, things like that. Net Zero is showing this waste can become a carbon sink, a soil booster, even an energy source. If that potential is locked up in farm leftovers, what other materials that we currently just discard might hold surprising value? What other overlooked resources could be transformed into solutions if we just look at them differently?
Yeah. Makes you wonder what else is hiding in plain sight, doesn't it?
Something to chew on. Thanks for joining us for this deep dive.